Okay, guys, so now let's continue from our introduction or summary that I've just done from my previous lesson. So, ladies and gentlemen, let's now focus on vertical projectile motion in one dimension. So, we are only going to be discussing vertical projectile motion in one dimension. Okay, one can still write 1D. Okay, very much important, ladies and gentlemen. Remember, please do make sure that you've got something to write where you'll be writing your notes. And remember, not everything that not everything that I say I'll be writing it down. So it's advisable that you just watch this lesson without having to write anything down, and watch it for the second time where you apply your mind, trying to understand some of the information that I provide. Watch it for the third time where you write down the notes. Soon as you've watched it 3 times, then you can move to the next video. Okay, very much important, ladies and gentlemen. So guys, can I quickly explain to you what is meant by projectile? So let me just write it down. Projectile. Okay, so I suppose you can just listen to what I'll be saying and write it down if need be. So ladies and gentlemen, a projectile simply means an object upon which the only force acting is the force of gravity. Okay, very much important, ladies and gentlemen. We've got different type of forces. Okay, you can have a applied force, you can have a frictional force, you can have what else, ladies and gentlemen? You can also have force of gravity, you can have tension. We've got multiple types of forces, ladies and gentlemen. So in this case, when we talk about projectile, okay, we are referring to an object upon which the only force acting is force of gravity. So that means for an object which is thrown vertically upwards, this could be a tennis ball. Okay, it could be thrown vertically upwards. It could be dropped from the top of a building, or otherwise it could be an orange or an apple falling from the tree, falling downwards. So when we talk about projectile, we are referring to this object, ladies and gentlemen, whereby it's only the force of gravity, okay, which is acting on this particular object. So that means there is a force acting, but not force, applied force or force applied. Okay. And again, ladies and gentlemen, there is no frictional force which could be as a result of the wind. Obviously, in real life, we've got wind. So for an object which is falling downwards, there might be wind moving sideways, which will have an influence on this object which is falling from the tree. Okay, so when we say in one dimension, ladies and gentlemen, just think of it falling from the top straight downwards. Okay, not falling down and moving in a funny direction as a result of this external wind. Okay, so that's why we are saying a projectile is an object upon which the only force, ladies and gentlemen, acting is the force of gravity. No tension, no any other type of force, but only force of gravity. Okay, very much. So obviously, That means for an object which is falling, not necessarily falling, but which is being projected vertically upwards or thrown vertically upwards, this object is experiencing a force, obviously, in the opposite direction, which is force of gravity, as a result of gravity, ladies and gentlemen. That's why we refer to that force as gravitational force. Okay, so I assume you do understand what is meant by projectile. Okay, very, very much important, ladies and gentlemen. The other thing that you need to bear in mind as far as vertical projectile motion in one dimension is concerned, ladies and gentlemen, it's the use of equations of motions. Those are the equations of motions, ladies and gentlemen. So we normally use equations of motions to determine the position. So ladies and gentlemen, we use these equations of motions to determine the position. Okay, very, very much important, ladies and gentlemen, to determine the position. Most importantly, never mind my handwriting, never mind my spelling. Okay, I suppose you're able to clearly hear as I speak, so you can just make sure that you write everything correctly, because remember guys, you might need to use those notes by the end of the year. So it's very, very much important that when you write your notes, you write neatly, and again, you write correct spelling. Okay, so remember guys, you may use equations of motions to determine the position, the velocity, and the displacement. Okay, so ladies and gentlemen, we use those equations to determine the position, the velocity, and most importantly, the displacement at any given time. Very, 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 very much important, ladies and gentlemen, at any given time. Okay, so the other thing which is very much interesting that you must also bear in mind as far as vertical projectile motion in one dimension is concerned, ladies and gentlemen, we normally sketch graphs for position versus time, velocity versus time, and acceleration versus time. Most importantly, ladies and gentlemen, for different scenarios. Okay, I'm going to quickly explain those different scenarios, but for now, let me just write this down, because it's also important that you write it down as part of your notes. Okay, we also sketch graphs graphs for position versus time. Ladies and gentlemen, I'm not really sure if I should use the symbols or just write it down, but because I've got limited space, you can just listen as I say, but I'll refer to this as let me just use X or Y in some instances, but for now let me just use X, which represents the position, and say versus time. Okay, and again we sketch graphs for velocity versus time, velocity versus time. Okay, very, very much important, ladies and gentlemen. And again, acceleration versus time. So acceleration, let me just represent it by let me just use A and say acceleration versus time. Okay, ladies and gentlemen, before I give you or explain to you the scenarios, let me just explain in terms of why and what else. A as acceleration. Remember, ladies and gentlemen, you may have a car which is moving obviously horizontally in that direction or in that direction. Okay, so in this case, we refer to the displacement or the position in terms of x. Remember, from the Cartesian plane, we've got the vertical line as y and the horizontal line as x. So that means for object moving horizontally, we represent the position in terms of x, okay, and the acceleration in terms of a, okay. But for objects being projected vertically upwards or downwards, ladies and gentlemen, we refer to the position as y, okay. And in this case, horizontally it's acceleration, vertically we refer to the gravity, okay. So ladies and gentlemen, do not be worried that much when you see a position being represented by x over there, and again acceleration being represented by a. So in some instances it might be represented by a y or g, depending on whether we're dealing with a problem where the object is moving vertically upwards or downwards, or otherwise horizontally to the right or to the left. Ladies and gentlemen, in case if you do not understand that part, do not worry that much. On the lessons that I'm going to be doing, I'll also explain, especially that part where I've got new symbols. So I'm going to explain in detail the old symbols versus the new symbols, and also go in detail into explaining that part. But I think most of you guys, you fully understand what I mean by that, okay. So ladies and gentlemen, remember I've just indicated that we sketch graphs for a position versus time, for velocity versus time, for acceleration versus time. For each of the following, ladies and gentlemen, let's just say the first one, a free falling object, okay, a free falling object. Can just write it down as part of your notes, okay. Very, very much important, ladies and gentlemen. So that means for an object which is falling freely, we can sketch the position versus time graph for that object. We can sketch a velocity versus a time graph. Did I say it should be for position versus time graph? We can also sketch a velocity versus time graph. We can also sketch acceleration versus time graph, okay. And again, ladies and gentlemen, we can also sketch 3 of these types of graphs for an object thrown vertically upwards, okay. Remember guys, for a free falling object, someone can be standing somewhere over there at the top of a flat, or otherwise if someone is somewhere standing in the balcony, they can just drop an object which will freely fall downwards, okay. So we're saying for this object we can sketch a graph of position versus time, velocity versus time, acceleration versus time, okay. And again, for the second one, we have just indicated that we can also sketch this for an object thrown vertically upwards. Let me just write it down over there. An object, let's say, thrown vertically upwards. Just write it down as part of your notes. Obviously, ladies and gentlemen, someone can be standing somewhere there and throw this object vertically upwards. So as that object it's moving upwards, we can represent it in a form of a sketch where we represent its position versus time, meaning after 1 second, 2 seconds, 3 seconds, 4 seconds, what is the position of this object? That can be represented in a form of a sketch. Okay, and again, when we talk about velocity versus time graph, we can tell after 1 second it will be traveling maybe at 4 meters per second. After 2 seconds, maybe it will be traveling at 3. After 3 seconds, it will be 2, and so on. Okay, so in terms of the acceleration, ladies and gentlemen, obviously as this object is being thrown vertically upwards, its acceleration decreases. So we can sketch a graph of acceleration versus time, okay, where we indicate that either as this object is being thrown vertically upwards, maybe its acceleration decreases over time. Okay, so ladies and gentlemen, this is just an example to take you through some of the stuffs that you need to be aware of, and most importantly, ladies and gentlemen, I'm going to teach you all of that information so that you're well prepared for your exams. Okay, and the other thing, ladies and gentlemen, the other thing that you need to be aware of is we can also represent all of this for an object which is thrown vertically downwards. Okay, let me just write it down and say thrown vertically downwards. You just write it down nicely. Remember, guys, the same person standing at the top of a flat can throw an object vertically downwards. Okay, very, very much important, ladies and gentlemen. Remember, this is different from when an object is being released. Okay, actually, for it to make sense, let's say for an object which is falling free, for a free falling object, let's maybe refer to an object which is just falling from a tree. Okay, just so that it makes a perfect sense. Like maybe, let's say a mango, after some time it just freely falls down. Okay, but otherwise the similarities between an object which is just falling from a tree and also from an object which is being released by someone who's at the top of the roof is that its velocity initial is equals to 0. Okay, so how does that compare to an object which is thrown vertically downwards? Ladies and gentlemen, you throw it downwards, so that means it starts at a certain speed. Unlike, for example, ladies and gentlemen, this is an object that I'm just going to release. Can you see? So this is an object which is freely falling vertically downwards. Okay, it's different from an object which is being thrown vertically downwards. I suppose you're able to notice the difference, ladies and gentlemen. So that's what I'm trying to explain and differentiate between an object which is free falling and object which is being thrown vertically downwards. So we are saying for an object which is free falling, thrown vertically upwards, thrown vertically downwards, can be represented in a form of a sketch where we represent its position versus time, or its position over time, its velocity over time, its acceleration over time. Okay, do not worry that much about what happens or how does the graph or the sketch looks like for an object which is thrown vertically upwards. I'm still going to make a video where I teach you about all of that information, but for now you just need to know that under vertical projectile motion in one dimension, this is all that you need to be aware of. This is not the only information, ladies and gentlemen. We can also represent an object which is bouncing, restricted to balls. Okay, so remember, guys, if you drop a tennis, you can either drop it or vertically throw it downwards, or otherwise throw it upwards. It will obviously go up, come down, it bounces. So ladies and gentlemen, what we're saying is that we can also represent an object which is bouncing. This is a tennis. It goes up, reaches a certain point, bounces, it hits the ground, it goes up again, it bounces. I hope you fully understand, ladies and gentlemen. The reason why we are saying restricted to balls is because a marking pen similar to this one, when you just drop it, can you see? it doesn't really bounce multiple times, can just bounce maybe once. So for us to achieve what we want to explain, ladies and gentlemen, we say a bouncing object, bouncing object, objects restricted to balls. Okay, so that means when we talk about bouncing object, under that we are looking at the balls. Okay, very, very much important, ladies and gentlemen. That also can be represented in terms of a sketch, where we sketch its position versus time, velocity and acceleration versus time. Okay, not only that, ladies and gentlemen, again, let me see, I think 1 2 3 4, yeah, I think this is all that you need to be aware for now as a high school learner. Okay, when you get to varsity, that's where you will see a different story. Okay, so for a given graph, ladies and gentlemen, so that means you can be given a sketch or a graph. Okay, so let me just write it down and say, for given graph of what, ladies and gentlemen? These are the graphs that I'm talking about. Okay, for a given graph of a displacement or position versus time, a velocity versus time, and acceleration versus time, ladies and gentlemen, you can determine the following. Okay, so that means you can be given a sketch, which could be a sketch of a position, velocity, or acceleration versus time. Okay, if you are given this, you can be able to determine the position. Okay, you can be able to determine the displacement. And again, ladies and gentlemen, you can be able to determine the acceleration or the velocity. Acceleration or the velocity at any given time, ladies and gentlemen. Very, very much important, ladies and gentlemen. So it means you can be given a graph which is for the position versus time. You can be able to determine any of this. Velocity versus time, acceleration versus time. Hope you fully understand, ladies and gentlemen. Remember, guys, for now, do not worry that much. All you need to do is just to be aware of this information that I'm providing. Okay, very, very much important, ladies and gentlemen. You just need to be aware of this information. I'm going to do some additional lessons where I teach in detail, until you fully understand all of this information. So it's in most cases where you might find that you watch these lessons for the first time, second time, and third time, and it still doesn't make sense, so it still doesn't help you to attack any given problem. But as soon as you watch up until the last lesson where I solve problems, that's when everything is going to make sense. Okay, and remember, guys, all of this information they are going to teach you in class. So if you want to be ahead of everyone else, just make sure not to wait for your teacher to get to each of these stages. Just watch from my first video until the last. I'm telling you, ladies and gentlemen, you will enjoy your teacher's lessons because you'll be able to understand each and every concept that they'll be talking about, and you will be asking some good questions, the most relevant questions, because you've got a bit of background. And I'm telling you guys, you will be able to solve any given exam question, which means we are getting distinctions in physical sciences. Ladies and gentlemen, as we move on, for a given position versus time graph, for a given velocity versus time graph, for a given acceleration versus time graph, we can describe the motion of the object for the following. Okay, I hope you understood what let me just write it down. So I'm saying, for a given position versus time, velocity versus time, acceleration versus time graph. I'm only writing in this way because of limited space, ladies and gentlemen, but I hope you're going to write everything nicely and neatly. And remember, guys, in case if you need the notes that I use or the notes that I've prepared for you guys, just drop us a WhatsApp on that number. Then I'll direct you to a platform where you can access all of the notes that I use to teach you guys. Okay, so for this type of graphs, ladies and gentlemen, you can describe the motion. You can describe the motion of the object for the following scenario. Okay, ladies and gentlemen, for a bouncing object, otherwise an object which is thrown vertically upwards and again thrown vertically downwards. Okay, very, very much important, ladies and gentlemen, that you take into consideration all of this information that I've provided. Guys, please do make sure that if you do not understand this information that I've explained to you guys, you just make sure to comment on the comment section. I will surely be happy to just do a special video where I explain or address your comments. Okay, but I think almost everything is clear, guys. I think almost everything is clear. So this is all that you need to know. Okay, nothing much, nothing less. I can guarantee to you that if you can be able to grab all of this information, you will be ready for your final exams. Okay, very, very much important, ladies and gentlemen. So please do make sure that you write down your notes neatly and you don't lose those notes. But I can tell you, if you can write down these notes and make sure to practice regularly, they will stick to your head. You will get to a point where you don't need to refer to the notes, but instead just refer to your mind. Okay, and it's reliable to refer to your mind, because at any given time, in case if you come across a problem under this chapter, you can easily solve it without having to refer to your notes. Okay, so that means, in short, you won't need your notes to solve problems related to this chapter. So ladies and gentlemen, on the next video, I'm going to be focusing on the definition of concepts of vertical projectile motion. Okay, so it's very, very much important, ladies and gentlemen, that you fully understand what is meant by acceleration, what is meant by average speed, what is meant by average velocity. Okay, so that's where I'm going to discuss to you guys the difference between the displacement and distance, and again defining in words the speed and the velocity. Okay, very, very much important, ladies and so everything that we'll be doing will actually be guided by those equations of motions. Okay, so before I can teach you all those formulas, or rather steps to using those equations or formulas, you need to understand what is meant by speed. Very, very much important, ladies and gentlemen. You need to understand what is meant by acceleration. Okay, so that's what I'm going to be doing in the next video, of which I encourage you to watch it from the start up until the end. Okay, so ladies and gentlemen, I suppose you enjoyed this lesson, and please do make sure to give me feedback if it was one of those useful lessons that you've had. And again, in case if you need to drop me a comment, please do make sure to drop a comment, of which I'll address by simply responding to your comments, or otherwise doing a special video where I address your comments. Okay, so ladies and gentlemen, thanks very much for joining. My name is Desmond and I'm out.